Hi, this is Dr. Hassan Abdullah with the course Web Applications Programming. And the topic which we are covering in this video lecture is topic number 6, which is databases. Because for the web applications programming, the architecture which we are following, which is the three-tier architecture, and the basic and the fundamental part of that architecture is capturing the data, storing the data, processing the data. And so data is the bread and butter. So are very important. And in this video, basically, we'll be talking about different aspects of a database. And this video, like the other videos, uses the supplemental website easymcq.com/goget, which is a learning management system. And this is way ahead of the traditional approach of having slides and those ancient slides which are static, which are passive, which are non-interactive, and so on. So this is a quantum leap in that domain, and you will benefit from it. And how you want to use it and how you should be using it, that is shown in these 6 videos, which are available at the address in front of you. Or you can go to my YouTube channel and go to YouTube and try and type my name, Dr. Hassan Abdullah, and it will take you there. The videos are available there. The videos are also available on the canvas. So what this personalized learning management system does is that it provides you full text search over the content of all the material, advanced search, basic search, and if there's a visual disability, it will take care of it. You can customize it, and everything is presented in the form of a hierarchy and bullets and details. And you can do online exam, practice yourself. You can track your progress, so you don't have to note anything. And this is optimized for mobile phones. So I would strongly urge you to look at these videos. Then the other approach, which is a benefit for you, is that the question and answer based approach. This is not a passive approach. This is a progressive approach. This is an interactive approach. This is an engaging approach, and it challenges your mind. It challenges your thought process. It's not that just I write a title or a topic and then discuss it. So I pose a question. There's going to be real life questions, real world questions, and of course that triggers the thought process. And this is the thought process in which we are ahead of the machines. So that's the purpose of to sharpen those thought process and skills. So, what are the topics that will be covered are listed in front of you in this course, and one of those topics is the databases. Now, within databases, what we will be covering is these are the questions and answers which are listed before you. There are 12 questions and answers. So, this video will be covering the first 6 or 5 of those questions and answers. So, video number 6A. And of course, this is just to give you an idea, to give you a concept that what will be you coming across. Because then we'll move on to the actual supplemental website and click on those wonderful questions and look at all the answers and the details. So this is for 6A. So we are now at the supplemental website, easymcq.com/goget. And these are the course, the lectures or the videos which I mentioned, that how to use the tool. So the approach in this course is the question and answer approach. So what are the benefits of that approach? You have to watch that video. And how the content is covered, how the navigation takes place, you need to watch this video. And how the space is optimized and how the drop down menus work, you need to watch this video, and so on. So let's go back and go on to the course Web Applications Programming, and we move to the topic which we need to cover in this video. And that topic is the sixth topic, which is databases. So databases, now many people have call our databases by different name, and that not only is a name, but that is also how it is perceived, and what features are considered, and what constitutes a database. So that's the question, and the bullets are, so for some people, or some, as a matter of fact, for some certain applications, database is a body of data. That's about it. So it's data, and it is organized in a certain way, and that's about it, right? And of course, that has limited functionality. So then is something called as a database, which is actually a database management system. So that includes the commands and the way to execute that commands on top of the body of data, right? So that is a database as a software, and which includes the body of data. And then there is another view, which is the database as a combination of data, software, and custom procedures. So, for example, the custom procedure is that you need to register for a course, or for example, you need to withdraw money or make a deposit in a bank, or you need to pay at a hospital. So those are the custom procedures. So those custom procedures run over that database management system, which runs over the body of data, which is the database. Okay. So this is what I mentioned is given in more detail here. So if I would highlight it, so database, the body of data is simply a collection of data organized for storage and retrieval. Because if the data is not properly organized, then it takes a lot of time and effort, right? So data has to be stored in such a way that it's organized and it is easy to retrieve. But it is like it is raw information, all right, and it's structured in the form of. So this raw information, basically, if you look at the classical definition of information, so information is based upon by processing the data itself. So we can like, and to get that raw information, we need to have a database management system, which is written over here. That's what we need. So for a body of data, data is stored in a predefined format. For example, the name is of type character. The date can be of type character, but it's better the date should be of the date type. And then we have certain binary variables, which is better to we have binary data type instead of storing them as numerical values, and so on. So, for example, a very ancient example of a library database data might include book titles, authors, and publication dates, of course, but there is no software which is managing and interacting with it. Okay. So then is the database as a software, which I mentioned, like a database management system. And some of those examples are, for example, MySQL, and of course, Microsoft SQL Server also. So this course which I have developed, this is centered around MySQL, which is a DBMS, database management system. Why? Because its hosting is fairly cheap. Okay, it's fairly cheap, and you can get good performance for not very large databases. You can get fairly good performance. All right. So then the database is a combination of data, software, and custom procedures. So what are those custom procedures, for example, which are basically triggers? Trigger means where something initiates them. Okay. For example, e-commerce database might include custom procedures for automatically updating inventory when an order is placed, generating invoices, calculating shipping costs. So these are the procedures. Okay. So similar procedures will be not similar, but procedures will be in an academic domain, in a healthcare domain. They will be different, but procedures are there. So if I could zoom in here, right. So focus, database has a body of data, data storage, and organization. That's it. Database management system is a software, and this is what we are interested in. Our course is about data, software, and custom procedures together. That's our course. That's what we are interested in. Example: simple file storage for body of data. Database as software is MySQL and Oracle DBMS. What we are interested in, not really enterprise systems, because that would require a more powerful database. What we are interested in, custom workflows and databases. So custom workflows, okay, and databases, not really e-commerce, because that's more involved application. And use cases for this is solving complex problems through automation and customized processes. We are not towards complexity. This is a undergrad level course, so we are not interested in complexity, and we are not interested in creating enterprise level applications. Okay, that's a daunting task. All right. So now we have decided that what we consider as a database constitutes a database management system and stored procedures. Okay, those procedures, as a matter of fact, go into the middle tier. All right. So how that data now that you should know all these things. Okay, I'm not going into detail because there is a whole course available at easymcq.com on database management systems, which is a fairly extensive course. So just a crux. I just objective is that you should know sufficient amount about databases so that you can develop sound applications. Okay, web-based applications. So what are relational databases? Relational databases is basically a mechanism in which how the things which are important in a business domain, how they are related to each other, how they are stored. That's why relational database. Okay, I'll explain it to you. So that consists of tables, and tables have rows. Okay, and there are multiple tables, right? And then is the primary key. So primary key is an attribute of a record, right, which uniquely identifies that record. For example, a social security number, for example, vehicle registration number, they are usually unique within a country. Okay, so they are used as a primary key, so you can uniquely identify a person using the, and of course phone numbers are unique also, but a single person can have multiple phone numbers, so that is not a primary key. You need to add something more to it to make it unique. And then is the foreign key. So foreign key is a key, right, which is a primary key in one table. Okay, all right, but say for example, okay, I'll show it to you. I'll show it to you so it will become clear. Normalization means that as we develop the database and we have collected the data, the objective is to partition the data in the tables. This table we are referring to, partition the data in the table such that there are less dependencies, there is less redundancy. As a matter of fact, there is no redundancy, and there is a limited overlap, right, among the contents of these tables. That is called as normalization. So there's first normal form, second normal form, and so on. I'll give you the examples. So the benefit of normalization is, of course, you what you do, you write something only once and you read something once, so it gives good performance. Then are the ACID properties. This is not ACID, ACID, and it stands for certain. It's the abbreviation. I'll explain it to you. And then is the SQL query. SQL. So when if SQL query can run on a certain way data is stored, then that certain way of storing the data is called as a relational database. Okay. So foreign key is a column, a group of columns in one table that links to the primary key of another table. All right. So for example, let's look at example. Primary key I've already explained. So for example, in a database with table for employees and department, an employee might have a department ID, right? We are assuming that a person is only one in one department, and that links to the department ID in the department table. So in the department table, every department has a unique primary key, and in the employee table, every employee has a unique employee ID. So through these IDs we link the people. Okay, so if a person is assigned to a certain has certain assignments, so in that assignments, right, so the primary key of the employee is used as a foreign key in that assignment.
I'll give you some examples also. So that's the is okay. Normalization I have explained to you. So acid properties, ACID stands for atomicity, consistency, isolation, and durability. Now for relational models, that's the case. Atomicity means that when a SQL command runs, either it runs completely or it does not. So there's no 50% execution. So that's atomicity. Consistency, that the transaction brings database from one valid state to another valid state. Okay, for if you're interested in more, you should take that course. It is available on easymcu.com. Isolation means that the transactions which are executed, they do not affect each other. And durability means that once a transaction is executed, it is committed. Committed means that it gets saved, it gets completely executed, right? So it will remain in the database, the results, even in the case of a system failure, because the backups are taken. So then we have that SQL queries. We have so in the next topic we will go through all of these queries and many more queries also, SQL queries, and I give you examples also. So this is the relational base, relational database. So we have this students table. So ID is the primary key, and we have these courses table in which the ID is also a primary key, and then is the student courses. Okay, students courses, the students registered in the courses. So this is, so you see the this ID, this is the unique here, but that is repeating here. Okay, and the course ID is unique in the course table. It is repeating here because once the student can take multiple courses. Okay, student 1 is taking course Java, and student 1 is also taking course ASP.NET. That's fine. And student 1 is also taking the course which is number 3, which is NLP. Okay, so similarly, this student 3 is taking course number 3, which is NLP. So one student can take multiple courses, and one course can be taken by multiple students. This is fine. Okay, so let's move on. So what are entities, relationships, and tuples? So this is some terminology, right? So let's look at it. So entities are things which are of significance in a business. Business, it does not mean that selling or buying things. Business means the domain. So for example, in the domain of education or a university, a student is an entity, a professor is an entity. And remember and understand that entities are not always physical. A course is an entity, but course is not physical, right or not? And of course, classroom can be an entity, which is a physical thing. And relationships are how those entities are related. For example, this student is registered in a certain course, so that is the relationship. And tuples are the records in the table. So entity is a distinct object or concept about which data, which is of course of significance in the domain. Okay, so it may be physical like a car, or it may be abstract like a course or event. And entities have attributes. Okay, entities have, so for example, student that might have student ID might not usually have a name and email address and so on. All right, so they are typically represented using the relational model. So what are relationships? Relationships are how two or more entities are related to each other. For example, student and course are related because a student registers for a course. Okay, and these relationships can be one to one, one to many, or many to many. Many to many, that one student can register in multiple courses, and one course can be taken by multiple students. So we need to have certain mechanisms of working with them, many to many. And of course, we can have one to one also. One to one means that this student has this social security number, say for example, or this faculty member, this parking space is for this faculty member, or this office is for this faculty member. So that's a one to one relationship. So we don't go into lot of details. And how those relationships are established, they are represented by the foreign keys, which we have discussed. So tuple is essentially a row in a table of a relational database, right? So the student table has a tuple, student ID, name, and email address. So that's one record. Okay. So we are going through some definitions. So let's this will make it more clear. So I zoom this. So this is a table. Okay, this is a table or set of entities. This row is a record or a tuple. Okay, sorry, and this name of the entity student is the attribute. A student has a name, right? A student has a section, date of birth, and a gender also. And a record, which is in yellow, is a row, tuple. And this is an entity, okay, and this is the value of the entity. Section C is the attribute value of the entity. Okay, so this is how it works. What is meant by normalization? Basically, I will not, because this is, we are going to be working with fairly simple scenarios, because we have a lot of work to do with reference to SQL and PHP and HTML and cascading style sheets. So normalization, what it does is minimize redundancy and dependency. Okay, and obviously when redundancy is reduced, efficient data storage and maintaining data integrity also, and it gives you speed also, because if you have minimized redundancy, then you'll be storing only once instead of storing multiple times. Okay, so then we have the definition of normalization. Let me give you one example here so it will become clear to you. So we have this person Thomas Mueller has the knowledge of Java, C++, and PHP. Now this is not even first normal form. For to be at first normal form, every cell, say for example, or a column will have a single value. So this is so Thomas Mueller, right, has knowledge of C++, PHP, and Java. Right now, you would say that this is a repetition here, but fixing this is more time consuming. Okay, so this is first normal form. Now, for some database to be in second normal form, it should be in first normal form. So this is the case in which there is a lot of dependencies among the records. So you have this ID set, you have Mueller and the professor ID, Smith, and the grade the student got. So this is split into three tables: student table, student ID, primary key; professor table, student professor ID and professor name; and the grades. This is in second normal form. Okay, so and of course the third normal form also. For it to be in third normal form, it should be in the second normal form. So what is entity relationship modeling? Now you will be doing modeling, you will come across modeling when you are developing an application and you talk to the end user, and the end user explains the requirements to you, and you use those requirements to create that entity relationship modeling or the diagram, and from that diagram you move on until you actually cut the tables. Okay, so it is good to know this, but this course is not about databases, so we are not going to go in a lot of details. So it's a conceptual framework in database design to visually represent the structures and relationships of entities within a system, so that it becomes very convenient and easy to communicate with the end user, to tell them. Okay, so we have this entity relationship diagram which has the entities, and entity like a student has an attribute like name, social security number, email address, and relationships. The student is taking a course, okay, with a certain professor, say for example, and they are real world objects or can be concepts also. And this one to one and one to many I already explained to you and will not go into more details. All right. Okay, so explanation of these things, entities in ER modeling. object or concept that is distinguishable from other. So a student is clearly distinguishable from a class, and the class is clearly distinguishable from a professor. All right. So attributes are represented by ovals in an ER diagram. So there's certain notation, and then you have these relationships. Then you have the cardinality and participation constraints. Cardinality means the number of instances of one entity that can be associated with another entity or relationship. Like, for example, one to many. Okay. And the ER diagram presentation, I'm not going to go into a lot of details, but you should know about these things. So, entities are usually rectangles, ovals for attributes, and diamonds for relationships. And so, this over here is we have an ERD, so professor, student, and course, they are entities shown by yellow color. And we have these ovals, which are the attributes shown in blue color. And we have these relationships. So, professor teaches this course, so that is a relationship, right? And then the course has a certain rating and so on. Okay. So now we move on to the next set of 5 questions and answers.